Now we are solving the fourth question. It's a very simple question. See, if areas of two similar triangles are equal, show that they are congruent. What is given, children? We have given two similar triangles and their areas are equal. Okay, let it be triangle ABC similar to triangle DF. It is given in the question. And also their areas are equal. Okay, that means area of triangle ABC equal to area of triangle DEF. Okay, this is given. Okay, these are the two given conditions in the question. And what we have to prove? We have to prove that triangle ABC is congruent to triangle DEF. It's very simple, children. See, first of all, it is given that two triangles are similar, so that you can apply area ratio theorem. That means area of triangle ABC divided by area of triangle DF equal to square of their corresponding ratio of their corresponding sides, that is AB by DE square, or this can be equated to BC by EF, okay, whole square, and that is equal to AC by DF whole square. This is by area ratio theorem. Okay, and what we have to show? We have to prove that these two triangles are congruent. From similarity, we have to prove that congruent. Children, see, how can we show that when two triangles are said to be congruent? If all angles are equal and all sides are equal. Angles must be equal and the sides also equal. Okay, see, here being they are similar, they must have equal angles, but their ratios are in proportional. But we have to show that if the sides are equal, our condition is okay. That means those two triangles will be congruent. It is clear, children. So what is our aim? We have to show that the sides are equal. Okay, sides are equal. Okay, and children, here being this area of triangle ABC divided by area of triangle DF. See, being these areas are equal, area of triangle ABC equal to area of triangle DF. If you take this in denominator, okay, that is area of triangle ABC from this, okay, divided by area of triangle DF. Can we equate this is equal to 1? When this comes in the denominator, okay, here you will get 1. Then only that 1 into this will be equal to area of triangle ABC. Okay, so from this you will be getting the ratio between, that means their ratios are same, that is 1. So our next, we are going to apply this on this area ratio theorem. That means from this, okay, from equation number 1, okay, you can substitute here this LHS part is 1. 1 equal to AB by DE whole square, okay, and ABC by EF whole square is also 1, okay, and the same way AC by DF whole square equal to 1. It is clear, children, that is area of triangle ABC divided by area of triangle DF equal to the square of ratio between their corresponding sides. So you can take 1 by 1 ratio, the square of the ratio between the corresponding side, and we can equate it to 1. That is what I have done here. It is okay? Yes. So from this, the next step our aim is to show that the sides are equal, okay, for both the triangles. That is AB square, okay, divided by DE square equal to 1, or AB square equal to DE square. Understood? Or by taking the square root, you will be getting AB equal to DE. AB equal to D. I have taken this alone, this one, okay, and you can equate AB square divided by DE square equal to 1, which means AB square equal to DE square, and hence you will be getting AB equal to DE. Okay, one of the corresponding sides are equal. And here the second one, the same way, ABC square equal to EF square will be going to RHS. Okay, so EF square, hence you can equate BC equal to EF. Okay, the same way, AC square equal to DF square or AC equal to DF. See, suppose children, these are the two similar triangle ABC, and here comes DEF. What we have seen, AB equal to DE, this side and this side equal, BC equal to EF, BC equal to EF, okay, and in the third side, AC of triangle ABC equal to DF of triangle DF. And since they are similar, it is given angles are already equal. This angle D, corresponding angles are equal, and now we have seen that the corresponding sides also equal, which means triangle ABC is congruent to triangle DF by SSS criteria. These two sides are SS congruence criteria is there. Okay, that means now we got that if two similar triangles having same area, definitely they will be congruent. Okay, but this is not for all that similar triangles. Okay, but if two triangles are congruent, all congruent triangles are similar, but its converse part is not okay. But under only this condition, if the similar triangle is having same area, we can easily show that they are congruent. Okay, so this is all about the fourth question. Now we are solving the fifth question. In this question, D, E and F are the midpoints of sides AB, BC and AC of triangle ABC. Find the ratio of areas of triangles DEF and ABC. Okay, we can start this proof, children. What is given? It is given that D, E and F are the midpoints of side AB. So we can mark D as the midpoint of side AB. Okay, so let it be D. And E is the midpoint of side BC. And finally, F is the midpoint of side AC of the triangle ABC. Okay, in order to get the ratio of areas of triangle DEF, that means we have to form a triangle, okay, by joining these points. Okay, now you can see the required triangles. That means triangle DEF, this triangle, okay, and triangle ABC, the big triangle, the whole triangle. And what is asked, children? We have to find the ratio of areas of triangle DEF and with the area of triangle ABC. Okay, this is what is asked in the question. Okay, see, since it is given that D is the midpoint and E is also the midpoint, you just join this line. Okay, that means we will have a line segment D, okay, which will be parallel to the other side of the triangle AC's other side. That means we have taken the midpoint of AB and BC. So what is the third side of the triangle ABC? That is AC. Okay, so the line segment joining the midpoints of these two sides will be parallel to this, the third side AC, that is by midpoint theorem. That we have learned in the 9th standard. Okay, so by midpoint theorem, what you can write, DE, this line segment, okay, is parallel to AC. See, children, that is DE parallel to AC. Okay, which implies this DE, by midpoint theorem we can write one more thing relating this DE and AC. This line segment is half of AC, that is parallel line is AC. So you can write this DE equal to half of AC. This is because midpoint theorem. Midpoint theorem. Is it clear, children? Okay. The same way, since E is the midpoint and F is the midpoint of the sides BC and AC, so the line segment joining E and F will be parallel to this side AB. Okay, that means can you write this EF parallel to AB by midpoint theorem? Okay, so you can relate this EF, okay, EF equal to half of AB. Okay, so now we have seen that D is half of AC, EF is half of AB, and we have one more side, that is DF. That means the line segment joining the midpoints of the sides AB and AC, that will be parallel to BC. That means you can write DF also parallel to BC. Okay, implies DF equal to half of BC. Okay, this all result we got by midpoint theorem. Okay, and what is asked, children? We have to prove that we have to get the ratio of areas of triangle DEF and area of triangle ABC. See, if we can show that the triangle DEF is similar to triangle ABC. Okay, you can apply is similar to triangle ABC. You can apply area. See, children, if you can show that this triangle DEF is similar to triangle ABC, surely we can apply this area ratio theorem. So what is our aim? We are now going to show that triangle DEF is similar to triangle ABC. For that we are taking this result. Okay, that means from this first statement, first equation, from this DE equal to half of AC. Okay, can you write, we are taking the ratio, this DE is the side of this triangle DEF, DE, and AC is the side of the triangle ABC. So I am taking their ratio, that is DE divided by AC. What is this? What is this? So I am taking this AC to denominator into LHS. So here this RHS will be 1 by 2. Okay, so I am writing this is equal to 1 by 2. Okay, and from the second equation, this can be equation 2, this can be equation 3, and this is the first equation. Okay, from 2. Okay, again we can see that EF is the side of the triangle DEF and AB is the side of big triangle AB. So I am taking their ratio, that is EF divided by AB equal to 1 by 2. Okay, and from equation number 3, DF divided by BC, I am taking this BC to LHS. So we will get the third ratio, DF divided by BC is also 1 by 2. Okay, from equations from 1, 2 and 3, we have this very important result. Children, what we have got now here, in triangle DEF and in triangle ABC, we have seen that the ratio between their corresponding sides, that is 3 sides of one triangle DEF and the 3 sides of the another triangle ABC, they are in same ratio. That means these two triangles are similar under SSS criteria. Why it is SS? Because we have taken the ratio between the corresponding sides of these two triangles. Understood? See, children, DE by AC 1 by 2, EF by AB equal to 1 by 2, and also DF by BC equal to 1 by 2. Okay, so the three ratios are being same. You can write this triangle DEF is similar to, we can write the correct symbolic form, even if in this question that correct symbolic form is not a matter, because we should get the result answer in terms of area. Okay, that means area of triangle ABC, and that is equal to the area of the same triangle in terms of CBA. Okay, see children, if I am writing the same triangle in case of BCA, what is the problem children? The area will be the same. This is only when in the question is in terms of area. Otherwise, this is not possible. Okay, so anyhow, we are writing correct symbolic form. Okay, so triangle, match with this result we got DE and here AC. Okay, so if I am placing AC and the third vertex must be B, let us see if this will be okay for the remaining two ratios. See EF and AB, but here second and third BC will come. But we can't make any change here in AC, but it can be also written in the form AC equal to CA. Okay, so I am writing here CA. Let us see if writing here CA, if all the three will be ready, this will be the correct symbolic form. Okay, let us check. So AD by AC, AC equal to CA doesn't matter. EF by AB, EF, AB no problem, second is also okay. And DF by BC, DF and BC, CB equal to BC, that doesn't matter. So this is the correct symbolic form. Okay, so these two are similar under SSS similarity criterion. Hope that it is clear children. Okay, if so children, what we have now, we have in this step, we have proved that these two triangles are similar. If so, you can apply area ratio theorem. Okay, so by area ratio theorem, the ratio between the areas of two similar triangles, how can we represent? Area of triangle DEF divided by area of triangle CAB. See children, area of triangle CAB equal to area of triangle ABC. The reason I already told. Okay, we are talking about same triangle ABC. So you can write that in terms of BC or CAB, that doesn't matter. Okay, so this is equal to the square of the ratio of their corresponding sides, isn't it? So what is that? DE by CA or AC whole square, that is, we have seen that is 1 by 2. So 1 by 2 whole square. Okay, what is 1 by 2 whole square? 1 square is 1 by 4. Which means area, then we are getting the answer in terms of ratio of areas of triangle DEF and triangle ABC. So we are writing in ratio form area of triangle DEF is to, ratio means the symbol is to area of, being this both areas are same, CBA or ABC. So I am writing here triangle ABC. Okay, equal to 1 by 4 is 1:4. Okay, x is to y is x by y. Okay, that is a result. So 1:4. So this is the result. That means the area between the area of triangle DEF is to area of triangle ABC is equal to 1:4. Now we are solving problem number 7. Here comes the question. Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of an equilateral triangle described on one of its diagonals. Okay, that means here we have a square ABCD and an equilateral triangle with described on one of its sides, either AB or BC or CD or AD. According to our convenience, we can mark an equilateral triangle with one side, one of the side of the square ABCD. And another equilateral triangle must be described on one of its diagonals. We know that a square has two diagonals. Okay, so another square must be drawn with one side equal to the diagonal of the square. Okay, that is the condition. So first we can draw these two equilateral triangles. Okay, that means here we have an equilateral triangle with the side BC. I am going to draw an equilateral triangle on that side of the square ABCD. Okay, so I am taking a square of side, length of the side equal to AA. Okay, all the sides are equal, being it is square, and an equilateral triangle on the side BC. We have marked the side of each side of the square is A. That means here equilateral, being it is in equilateral, all sides are equal, all angles are equal. Okay, so here 60 degree, here comes 60 degree, here comes 60 degree, and here BCD. Okay, so BCE, let it be E. So we have now an equilateral triangle BCE with the side A, because we have taken a square of side, length of the side as A. And another condition, we have to draw one more equilateral triangle. Okay, that should be described on one of the diagonals of the square. Okay, we know that a square has two diagonals, children. So I am joining B with D, and I am describing another equilateral triangle with the side equal to BD. See children, here what is the length of the side of the second equilateral triangle? That will be equal to the length of the diagonal of the square according to the question. Okay, that means BD, since BD equal to diagonal of the square ABCD, what is the length of BD? That means by formula we know that it is square root of 2a, root 2a. Okay, this a is free from the square root, so root 2a is the formula to get the diagonal of the square with the side a. Here a denotes the side because this is a 90 degree. Okay, so a square, the square of the other two sides, and AD is the hypotenuse. Being the square, each angle is 90 degree, children. So applying the Pythagoras theorem, okay, the length of the square of the hypotenuse is equal to sum of the squares of other two sides. So a square plus a square, 2a square. So we need BD. So square root of 2a square is root 2a. That is how we got this formula. Or you have to by heart this formula. This is the diagonal, length of the diagonal of a square is always root 2 into a. Here a denotes the side. Okay, then come to this problem, children. We have to describe a square, an equilateral triangle with the side BD. Okay, so I am going to draw a square, an equilateral triangle. That means on this diagonal BD. See children, so BDF, this vertex can be F because we have marked here as E, so here vertex comes F. So children, here we have two equilateral triangles. Okay, one is on the side of a square ABCD, another one is described on one of its diagonals. Okay, so let it be root 2a. The length of each side of this equilateral triangle is root 2a, and each angle is 60 degree, being it is an equilateral triangle. So idea is clear, children? Okay, see here the equilateral triangle described on the diagonal of the square ABCD having the length of each side equal to root 2 into a, because BD is the diagonal and its length is root 2 into side. Okay, yes, then what we have to prove, children? We have to show that the area of an equilateral triangle described on one side of a square is half the area of this equilateral triangle described on one of the diagonal of the square. That means we have to show that area of triangle, which is a triangle described on side of the square, that is BCE. Triangle BCE equal to half the area of the equilateral triangle described on the diagonal, that is, which is that equilateral triangle BDF. This is what we need to prove. Okay, we have to prove that area of triangle BCE equal to half the area of triangle BDF. Okay. See children, here this this problem is based on area. Okay. See, we have area ratio theorem. What is that? The ratio between areas of two similar triangles, okay, is equal to the square of the ratio of their corresponding sides. In order to apply this area ratio theorem, the first condition itself, the triangles must be similar. The area ratio between the areas of two similar triangles. Okay, see children, here we have two equilateral triangles. See, I have marked the angles, each angle is being 60 degree. Okay, that means triangle BCE is similar to triangle BDF by AAA similarity criteria or AA similarity criteria. Okay, so that is the first step, that is, see, being triangle BCE and triangle BDF are equilateral triangle implies this triangle BCE similar to triangle BDF by AAA similarity criteria. Each angle equal to 60 degree. If so, if these two are similar triangle, we can apply area ratio theorem. Okay, that is the next step. That means here area of triangle BCE divided by area of triangle BDF equal to the square of the ratio of its corresponding sides. Okay, corresponding sides can be, see children, BC divided by BD whole square equal to the second corresponding side, the ratio between the second corresponding side, CE by DF and its square, okay, by ratio theorem equal to the third ratio is BE divided by BF and its square. This you got by area ratio theorem. This is by area ratio theorem. Okay, since these two triangles are similar. Okay, and here exactly which side we need? Okay, we can substitute here. We know the values of BC. BC is the length of one side of the square, and that we can mark it as A. We have taken the square ABCD with the side equal to A unit. And what is BD children? BD is the diagonal of the square ABCD. And by formula, what is the diagonal? Root 2 into A. Okay, that means root 2 into A and its square. Okay, I have substituted these values of BC and the BD in the first ratio. By area ratio theorem, this is area of triangle BCE divided by area of triangle BDF equal to A divided by root 2A whole square. Children, here what we can do? Here A by root 2A whole square is A square. A by B whole square is A square by B square. Substitute. Okay, give the square for both the numerator and denominator. And root 2A whole square. Okay, and in the next step, A square divided by root 2 into A whole square. AB whole square is A square into B square. We have to square both factors. So, root 2 square is 2 itself. Root x into root x is x, right? So, root 2 into root 2 is 2 itself. So, 2 and A square. You have to square A also. So, you will have now A square divided by 2A square. In the next step, you can cancel A square with A square. Okay, A square and A square. One time A square get cancelled. So, we have now 1 by 2 comes in RHS. What we have in the LHS, area of triangle ABC, not ABC, BCE divided by area of triangle BDF we have seen that is equal to 1 by 2. Okay, that means from this you can write that is this is equation number 1. Okay, what we need, children? Area of equilateral triangle described on one side of a square is equal to one side of a square. Here, which is that equilateral triangle? Triangle BCE. We have marked on side of the square ABCD. And its area is, so I am keeping this numerator, that is area of triangle BCE equal to, here we have got this is 1 by 2. Okay, so what this denominator when come to RHS, it will go under multiplication with 1 by 2. 1 by 2 is already there. So 1 by 2, this 1 by 2 into, I am keeping only triangle BCE in LHS. Okay, and this second equilateral triangle, area of equilateral triangle BDF. This is the required answer. See, children, area of triangle BCE equal to half the area of equilateral triangle BDF. This proof is clear, children. Okay, just we have applied the only result, that is the diagonal of the square is root 2 into A. Okay, and by area ratio theorem you can equate these two areas equal to the square of the ratio of their corresponding sides. Okay, hence we can easily reach into the required answer. Is it clear? Now we are solving the 8th question. Here we have to tick the correct options and we have to justify for our answer. Okay, here 4 options are given and here the question is triangle ABC and BDE are two equilateral triangles such that D is the midpoint of BC. Ratio of areas of triangles ABC and BDE is, options are given. So that means here we have an equilateral triangle ABC with the midpoint of BC is D. D is the midpoint, that means BD equal to DC. Okay, so here I already told ABC is an equilateral triangle. So I am going to take the side of this equilateral triangle as 2A. That means this side, length of AC equal to 2A. So definitely this BC also 2A and this side also AB also 2A. Because being this is an equilateral triangle. And what about its angles? Each angle is 60 degree. Being it is given that triangle ABC and triangle BDE also an equilateral triangle. Now we have the vertex B is here, D is also here. Okay, being D is the midpoint, okay, BD will be equal to DC. D is the midpoint of BC, that is given. So we have to draw another equilateral triangle, okay, with the side BD because BDE. Okay, that means I am going to draw another equilateral triangle BDE. Since BDE also an equilateral triangle and we have seen that BD is the midpoint and BC the length equal to 2A. Okay, so BD equal to half of BC. Okay, that means BC is 2A, so it's half, so 2 get cancelled A. So this side is A. It is clear, so the whole length is BC, being D is the midpoint, BD the length of that line segment, the side of equilateral triangle BDE, and it will be A. So you can mark another two sides also, D also A, being it is an equilateral triangle and this is equal to 60 degree each. It is clear, children. That is why I have marked the side of the big equilateral triangle ABC as 2A. So its half will be A. 2A divided by 2, that is the half of, that is the length of BD. Okay, and what we have to find? Ratio of areas of triangles ABC and BD. Okay, so we have to find the ratio of area of triangle first ABC. In ratio you have to keep that order properly. area of BDE in the denominator. Okay, what is the area of triangle ABC? Okay, being these two triangles are equilateral, you can again apply the area ratio theorem. That means that these two triangles are similar. So the area ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Okay, so we can select this sides accordingly, that is here BD, and here we have to take the side of BC first, because we have written the numerator, the equilateral triangle ABC. Okay, so AB by BD whole square Next, children, what is asked? Here we have now the side of each equilateral triangle. Okay, that is triangle ABC with the side 2A, and now we have another equilateral triangle with the side BD, and its side length of side is A, because it is a midpoint. Okay, and what is asked, children? Ratio of areas of triangles ABC and BDE. Okay, that means in ratio you have to take that triangles in correct order. Triangle ABC in the numerator and area of triangle BDE equal to. Children, can we apply here area ratio theorem? Yes. Why? Because these two triangles are being equilateral, they are similar, because all the three angles equal to 60 degree. Okay, so we can equate this a ratio between the areas in terms of square of the ratio between their corresponding sides. Okay, see, children, here AB divided by BD whole square. Square of ratio of their corresponding sides equal another corresponding side BC and DE. BC divided by DE, and that is equal to the third one AC divided by BE whole square. We are going to substitute any one of this ratio. Okay, AB being it is one of the side of the big equilateral triangle ABC, and its side is 2A. Okay, and BD is the side of the small equilateral triangle BDE, and its side we have seen that A whole square. Okay, we substituted only, we have taken these two sides. Okay, so 2A divided by A whole square. Okay, that is what is 2A whole square? 4A square divided by A square. So A square one time. So the ratio is, in terms of ratio, 4:1. Okay, you can see that in the third option, that is C, that is 4:1 is the ratio between these two equilateral triangles. Now the ninth question, this also MCQ type. Here we have 4 options are given. We have to select the correct option and we have to justify for our answer also. Okay, here comes the question. Sides of two similar triangles are in the ratio 4:9. Areas of these triangles in the ratio. That means we have to find out the ratio between the areas of these two similar triangles. Okay, having the ratio of their sides equal to 4:9. Okay, see here, what is this 4:9? This is the ratio of their sides, 4:9. Okay, and being it is similar, it is given these two triangles are similar. So definitely we can apply area ratio theorem. This is also one of the application problem of area ratio theorem, children. Okay, and by formula, by that theorem, okay, that is the ratio between the areas of two similar triangles. Okay, see, suppose if you want, you can take the name of the side triangle as a triangle ABC. Okay, triangle ABC and a triangle DEF are the given two similar triangles. Okay, DEF. If so, what is this 4:9? It is, according to the question, 4:9 is the ratio between their corresponding sides. And by the area ratio theorem, this area between, the ratio between the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Okay, this is the ratio of their corresponding sides, 4:9 equal to 4/9, because x is to y is equal to x by 9. Isn't it? X by y. Okay, x by y. Okay, so 4 by 9, 4 is to 9 can be written as 4 by 9. Okay, and its square. Because by area ratio theorem, that is square of ratio of their corresponding sides. Okay, so that is equal to 4 square. Okay, that is 16 and 9 square is 81. So in terms of ratio, 16 is to 81. Okay, so this is all about the 9th question. Okay, thank you children. Thank you for watching and supporting my channel. Thank you all.